Hey, hi everyone. So, today I'm going to talk about the concept, last concept for the first chapter of Indices. Okay, today I'm going to talk about the concept of standard form. Standard form. Hmm, why did it pop up? I have no idea. Alright, let's get rid of this first. Okay, good. So yeah, back to this. So I'm going to talk about the concept of standard form. And before I continue, I would like to give you the definition of what's the meaning of this term standard form. Okay, so in your textbook you might see this a times 10 to the power n, and over here let me talk about what is a and what is n. So a should be in the range of 1 to 10, and one thing to take note here is there is an equal sign here. Okay, I hope you can see this equal sign, and the equal sign for the next number here, 10. So what this means is your a must be, your a can be bigger or equal to 1, and it must be less than 10. Okay, so your a must be bigger or equal to 1, and it must be less than 10. So your a must be in this range. Okay, and next, and your n must be an integer. Okay, so some examples of an integer like 1, 2, 3, 4, and so on and so forth. Okay, so with this definition, let me elaborate with some examples so that you can actually make use of this definition to express your number in standard form. Okay, so let's start off with number 60,000 here. Okay, so in order to express this number 60,000 into standard form, so what you do is first you need to find out what's your a, and then next find out what's your n. Okay, so in this case you can actually see that your a here can be replaced by a 6. Okay, and then now your job is to figure out what is your n in this case. You can clearly see your n is actually 4 in this case, right? Okay, so therefore now your question you ask yourself is your this 6 bigger than 1 and smaller than 10? The answer is, so does it meet this requirement? So basically if you look at it, so this is your requirement 1, and then this is your requirement 2 in order to express your number in the form. So now the question I ask myself after writing down this form is to ask myself, okay, the first requirement. Do I meet the first requirement? So I look at my text here. So it meets the first requirement. So 6 is bigger than 1 and smaller than 10. And the next requirement I ask myself is my 4 an integer? The answer is yes in this case. So therefore, when your this answer meets the 2 requirements above here in definition, so you have successfully expressed your this 60,000 into standard form. Okay, pretty simple. And let me give you some more examples. So let me start off with another example. 17150. So your job is to figure out what is your a, what is your n, right? So bear in mind your a must be in this range. Okay, it must be between 1 and 10, and 10 is not included. So in this case, you can see your a in this case is actually 7.15, right? And then just have to find what's your n in this case. So you can see that your n is 3 in this case. Okay, if you are not confident enough, you can actually use a calculator to see if you can get this. Okay, so pretty easy. So now let me give you some more examples. Okay, let me give you some more examples. So let me give you a decimal number. Okay, so in order to make this into a standard form, what you need to do is find out what's your a and find out what's your n. Okay, so your a in this case should be, so bear in mind the first requirement, a must be between this range, and then your n must be an integer. Okay, so with these two requirements, the first question I ask myself is, what should be my a? Okay, so in this case, your a should be 6.5. Okay, meet the first requirement. Okay, next, now the question I ask myself is, then what is my n? Okay, so your n, so for the previous page, okay, over here our n is all positive integers. I hope you can see that. Okay, so our n here is positive integer. So for this n, so you can't use a positive integer, because if you use a positive integer, your this 6.5 is so much bigger than your 0.0065. Okay, so what you need to do now is you need to use a negative integer here. So what is the negative integer for n, such that you get back your this number 0.0065. So you can see that you are actually moving to the left. From here, you are moving to the left by 1, 2, and 3. So you are moving to the left by 3 decimal places. So therefore, your n should be negative 3 here. Okay, so next, so let me conclude this by having the last example. So let's say you have this let's say you have this decimal number, and first thing first, you have to express, so you have to find out your a first. So what is your a in this case? Okay, so your a must be in this range, right? So you can clearly see your a is 1.02. Okay, and then in order to make this 1.02 smaller, to get your this 0.0102, so you need a negative integer. So your n here is, so you just ask yourself, so your decimal point is here 1.02, so you're actually moving your decimal point to the left by 1 and 2 places. So therefore, if you move the decimal point to the left by 2 decimal places, so you should have a negative 2 here. Okay, okay, so you might be hearing some music in the background. So that's the music from one of my tenants, so just ignore that. Okay, so I have explained the definition of standard form with some examples, and now what I'm going to talk about is, so there are some short form you need to memorize for standard form. Okay, so let's start off with the first one. So 10 to the power of 0 should give you 1, right? So I hope you remember this. A to the power of 0 is 1, and a cannot be 0. Okay, so this is the one of the indices law we talked about in our previous lesson. You can actually refer to that video. Okay, then if I am going to go to the upper range of 10 to the power 0, so the next one you need to remember is 10 to the power 3, and 10 to the power 3 is 1000, right? Okay, and in and 1000 is actually called kilo. Okay, and if you want to use a, let me erase this first. So if you want to use a small letter to represent this kilo, you actually use K. Okay, so let me move up another level. So it's 10 to the power 6, and 10 to the power 6 is actually a million. Okay, but in terms of mathematics, or in standard form, we are actually using mega. Okay, we are actually using mega to represent this 1 million, and the letter you're going to use for mega is capital M. Okay, and the next one is 10 to the power 9. So 10 to the power 9 is 1 billion. Okay, so yeah, so over here we are using billion to represent, and the letter for that is B. Okay, let me refer to this table. Oh no, so you use billion for you use billion in our daily life, but in standard form, you should use giga. Okay, and the capital letter G is used to represent 1 billion. Okay, so if I'm going to go to the lower range below 10 to the power 0 or below 1, so let me start off with the first one. So the first one you start off with is 10 to the power negative 2, and you should get 0.01, and you are going to use center to represent this 0.01, and the letter you use is C. So I hope you can recall centimeter. So centimeter is actually your 10 to the power negative 2 meter. Okay, so that's your centimeter. Okay, now let me move one level down. So you have 10 to the power negative 3, and this will give you 0.001, and you are using B to represent this, and you are going to use a small letter M to represent this number. Okay, let me move down further. So it's 10 to the power negative 6, and you are going to get this. Okay, you're going to get this, and you're going to use micro. Okay, and the alphabet is this. Okay, the alphabet is this. Okay, to represent micro. Okay, the next one is 10 to the power negative 9. So I'm not going to write down the decimal number, but I'm going to write down the English word for it. It's called nano. Okay, and you're going to use a small letter N, okay, to represent this. Okay, so for your level, this is all you need to memorize. Okay, so 10 to the power 9. Okay, use giga. Okay, and use the capital letter G to represent 10 to the power 9. Okay, and subsequently you're going to use mega to represent 10 to the power 6, capital letter M. Okay, mega to represent 10 to the power 6, capital letter M. And you're going to use kilo to represent 10 to the power 3. And you are going to use capital K to represent this 10 to the power 3. And subsequently, so you need to memorize all this. Okay, it's a bit too much to some of the students, but that's the way it is. Okay, I would say if you are only asked to memorize this much of stuff, I think as a student, you ought to memorize them in order to score well in exams. Okay, so let me give you some examples then. So let's start off with this. Okay, so what do you have here? So let me express this in standard form first. I hope you remember standard form looks like this. Okay, so for this, okay, your A should be 1, and then your N is, you count how many zeros you have. 1, 2, 3, 4, 5, 6, 7. So 10 to the power 7, right? Okay, so now your 1 is between 1 and 10, right? So it fits the first requirement. And your 7 is a positive integer, and it fits the second requirement. Okay, so therefore this is instead of 4. But what if you want to use 1 times 10 to the power 7? So what if you want to use this to represent your 1 times 10 to the power 7? Okay, let me write it down here so you don't have to like go back and forth. So which one you should pick to represent 1 times 10 to the power 7? Okay, so you can clearly see 1 times 10 to the power 7 is actually closer to 10 to the power 6, right? Okay, so therefore, but over here is 10 to the power 7. Okay, so you have to give a 0 to 1 in front, so you 10 and then times 6. Okay, so therefore your 1 times 10 to the power 7 is actually 10. Okay, so I hope you know how to make use of standard form and some of the letters here used to represent standard form numbers. Okay, so let me conclude this with a final example. Okay, so let's assume you have this 0.120467. Okay, so to represent this into standard form, okay, so remember your standard form looks like this: A times 10 to the power n. Okay, and your n has to be between your 1 and 10. Okay, 1 is included, 10 is not. So you can clearly see this can be expressed into 1.20467. And what you're going to have is you're going to have 10 to the power minus 1, right? Okay, because your decimal point is here. Your decimal point is here. In order to get this, you have actually moved your decimal point to the left by 1 place. So therefore your n is -1. Okay, so you have already expressed this into standard form. And now let's look at this number. Let's look at this number and see how we can make use of the letters to represent this. Okay, so let me copy this to the previous page. 1.20467 times 10 to the power. Okay, so let me start off with this. Erase this first. So your answer is 1.20467 times 10 to the power negative 7, right? Oh, negative 1. Okay. So let me double check. Oh yes, so it's 10 to the power negative 1. So you can see that this whole thing, okay, is actually very close to the C here, right? Okay, so therefore you pick C. So, but your C here is negative 2, 10 to the power negative 2, right? So in order to get, let me give myself some space. So in order to get 10 to the power negative 2, okay, so you should give 1 0 to, this, right? So you give 1 0 to it, so you get 12 point 0467 times 10 to the power negative 2, okay? And therefore you get 12.0467 times. Okay, so okay, one thing to note here is this is your standard form. Okay, this part is your standard form. Okay, this is standard form, and this part is not standard form. Okay, I hope you realize that this part is not standard form. This part is to just make use of what we learn here, so that we can express this this manner. Okay, so that's about it today. So I hope you enjoy my video. If you have some questions, of course you can post it either on YouTube or Facebook. Okay, so thank you for watching, and bye.